Greetings. My name is Dr. Boyd, the chemist, and I'm coming to you on behalf of the Transformational Education Adventure Center, also known as the T-Center, which is located in McLean, Virginia. And today we're going to have another STEM lesson. Today's STEM lesson is about magnetism. Magnetism. And if you want to follow along with the experiment, here's what you can do. You'll need a magnet. I have this little fancy one here, but if you have one from your refrigerator, that should work too. Make sure it's the strongest one on your refrigerator though. And you are gonna need some paper clips. All right, I've got about a half dozen paper clips here. Okay, so what is magnetism? What is magnetism? Well, magnetism is actually part of one of the few fundamental forces there are known to man. It's part of electromagnetism. And there are a number of types of magnets that exist. Really, magnetism occurs when an object that is magnetic can draw another object to it. All right, so there are permanent magnets like this. This is a magnet. It's a permanent magnet. There are also fields, magnetic fields, like the Earth generates a magnetic field, all right? Then there are temporary magnets. There are some magnets that only exist for a space of time, all right? Temporary magnets. Today, we're gonna be dealing with a permanent magnet, like this one here, or like the one in your refrigerator. And we're gonna make a temporary magnet, all right? Pretty cool stuff. So let's check it out. Here I have my magnet, and I'm going to take one of these paper clips. I'm actually going to have it attached to the magnet like that. All right, so at an angle. You can see that it's not straight down, it's at an angle. All right, and you'll see in just a moment what I'll do with it. All right, so now I'm going to take another paper clip and see if I can attach it. All right, now keep in mind, paper clips are not magnetic. They are metal, and the metal that these paper clips are made out of can be pulled on by magnets, all right? But the paper clip itself is not a magnet. I should repeat myself or correct myself. The paper clip is made out of a magnetic metal, but it itself is not a magnet, all right? So what's happening here is this paper clip has become magnetized by the magnet here, meaning now it also can behave as a magnet, okay? So this paper clip is not touching the magnet, but it is touching a paper clip that has been magnetized. Now, if this magnet is strong enough, I should be able to attach another paper clip. Aha, all right? Now this paper clip is 2 paper clips away from the magnet, all right? Well, what can I do with it now? We know we have a magnet, and it must be reasonably strong because now we have 3 paper clips hanging off of it. And we know that this paper clip isn't even close to the magnet. There's 2 paper clips in between it and the magnet. So this paper clip is also magnetized. Now, what's really cool is if I take this paper clip slowly off of the magnet, aha, now none of the paper clips are attached to the magnet. However, they're sticking to each other. Why is that? Well, this is occurring because the first paper clip became magnetized, and then the second paper clip became magnetized, and now the third paper clip is being magnetized. All right, pretty awesome, right? So we have created a paper clip that is now functioning as a temporary magnet. While it is magnetized, it can actually attract other objects that are magnetic, okay? Now, let's see if we can do something. Let's see if we can attach more than just these paper clips on here. Now, I'll admit this is really tough and we may not be able to get any more. But let's see if we can get at least one more paper clip attached here. This will be difficult. Oh, maybe. Okay, I can't seem to get it to work with that one. Let's see if my refrigerator magnet will get it to work. So I have a magnet. Oh boy. Okay. There goes one. There goes two. Oh, I felt it pulling. It was trying. There goes three. There goes all 5 of my paper clips are attached, and 4 of them are attached to the one that's directly touching the magnet. All right, that suggests to me that the magnet that was on my refrigerator is actually stronger than the other magnet that I had there. Pretty cool, huh? One thing I want to mention about, notice I just took this off of here, and let's see. I put it on the table, and look at this. It's still magnetic, okay? So this temporary magnet I've created is strong enough that even though I set it down on the table and I separated it from the big magnet, it is still holding on to 2 more paper clips, all right? Wonder how long that'll last. That's an experiment I can try another time. One thing that's really important to know about magnets is that magnets have a north and a south pole. What that means is that they will repel each other if they get too close. So instead of coming together, a north pole will not touch another north pole. It'll push apart. But a north pole and a south pole will actually come together. So how do you know which poles are the same? Well, if you take a magnet and try to attach it to another magnet, what happens is it will find the opposite pole and automatically come together. But if I try just to push it onto one pole, it won't work. I can't get this magnet to stay here, all right? And you can actually feel it with your hands. That must mean that this end of this magnet and this end of this magnet are the same. Either they're both north poles or they're both south poles, all right? But notice when I turn this around, I can actually attach it, all right? So let's see it one more time. See, it doesn't want to attach that way. But if I bring it the other way around, it attaches. So I know what side of the magnet has the same polarity as another magnet, all right? Because they will repel if they are the same, a north to a north or a south to a south, but they will come together if they're different, north pole to south pole. All right, here is just a little challenge that you can try when you go home. Find a magnet. Get some paper clips. Find the strongest one you can find and see how many magnets you can actually attach to it before it no longer works. And I do just want to show you this. This is pretty awesome. I have these 3 magnets are still stuck together. It's been a couple of minutes and they haven't touched the magnet in a while. That means that this magnet is pretty strong because it has transferred some magnetism to this paper clip long enough for this to still be happening several minutes later. All right, with that, I want to say thank you and definitely watch the T-Center videos. All the videos for STEM lessons and other lessons are posted on the T-Center's Facebook page. You can actually go to the T-Center website and learn more about the wonderful things that are happening at the T-Center. So definitely check it out and I will see you later.